Now, the first experiment that was detailed on your sheet. Can you tell me and share, who can tell me and share with the class what the first experiment was on the sheet? And please bear in mind that I cannot see you on the chat. So please make sure that if you are giving a contribution, please make sure that it's a contribution that that we can see. Now, which way is up? That's it. Which one's up? Now you can see. All right, okay, good. So what was the first experiment on your sheet, on your revision mat? Have a look. What was the first one? Ah, okay. Is that what the experiment was? We can do that. We can certainly do that. So we have some carbonate here. Just got. I'm going to use a white surface so that you can all see what is going on. We've got a little light here as well, which makes it very effective. It says hoping. And you are suggesting that we have some copper carbonate. Now we have some copper carbonate here. Be very, very careful with it. Now that copper carbonate is green. Copper carbonate is green in color. Okay? And what we're going to do, we're going to take some of that copper carbonate, and you've suggested that we add some acid called sulfuric acid, is that correct? Yes? Let's give it a go.
Yes.
There we go. So moderate hazard, that means so long as I do not inhale it, touch it, should be fine. Should be good. We have a green, it's a lovely green. So we have some dilute sulfuric acid. Okay, this is not as concentrated, this sulfuric acid, as the acid that you have in car batteries. Car batteries contain acid. It helps with the electrochemical reaction that takes place in order to power up your air conditioning and your lights at night. Lights at night in the car, that's another lesson altogether. I actually did a YouTube video that featured it this week for my year 9s. You'll be able to study that next year. Xenon. What an amazing element xenon is. It's like bright daylight, but with a slight blue tinge. Very, very amazing. Can you do me a favor? Just nod if this is the right way round on your screen. Is it looking like, can you read it properly? Or is it mirror? Does it say dilute sulfuric acid? It's what? Oh, is it a bit far? But is it the right way around? So it, yeah, because it's mirror imaged on mine, yeah? Okay, right. So, Nada has suggested if I add some of this dilute sulfuric acid, now do we know what this hazard warning symbol means? Yes, go on. Moderate hazard. It does mean moderate hazard. It does mean moderate hazard. When we're talking about an acid, what kind of thing could happen to me if that acid of that dilution were to touch my skin?
It might burn my skin.
There wouldn't be too much of an effect. Not harmful. Suppose if it stayed on, it might be like I might get a little bit of harm, I might get a little bit of irritation. What could happen? do you think? Yes. My hand would die? What? Burn? No, no, no. No, no, no. You're thinking of someone else. There's someone else in the movies that has fire coming from their hand. What is it? Flame on. That's the Fantastic Four, isn't it? No, no, no. We don't talk about burning. Burning hands. That's not it. What could happen? Yes. Say that again? It could. No, 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 no. Not with this. Not with this. No. Corrode means that it would wear away, and I would then see muscles and bones, and the flesh would disappear. It would be like the Terminator. You don't know who the Terminator is because you're far too young to see that movie, aren't you? You don't know what the Terminator is. When you're old enough to watch that film, if you are brave enough, you don't have to watch that film, but if you are, you'll see the skeleton of the robot in the Terminator. No, 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 no. You don't have. That's corrode. No, no, no. No, this will do. We'll just give you a rash. We'll give you a rash. You'll just have like a red bits of irritation, a little bit like eczema, or maybe a reaction. And all you would need to do is you would need to just wash it off. Just wash it off. And it's very, very important for you to not get too scared about chemicals. Chemicals are wonderful. Don't get too scared about them. If you treat chemicals correctly, they are fascinating. So we've got some copper carbonate here. We've got some dilute sulfuric acid here. Let's add one to the other. Now, before I do, I need to ask you for the prediction for the metal carbonate reacting with sulfuric acid on your sheet. What is the prediction? So I'll come to, I'll lower everyone's hands, and then what I will say is I'll say, right, raise your hand if you have a prediction. We'll go to Taj first. Yes, Taj.
So what I wrote is the gas with carbon dioxide will form.
Carbon dioxide, yes.
And it will turn blue because of the formation of the copper sulfate.
Wow, that's very, very good. Is there anything else going to form as well, Taj? No? Oh, Yusuf Abu Kamran, you've got your hand up. Yes, anything else going to form?
Water.
Water. Now, it's going to be in dilute sulfuric acid, so it may not be easy to detect water forming in water, but we can't ignore that because the atoms that we start off with must be accounted for in the atoms that we end up with. Okay? So the atoms may be in some molecules, or they may be on their own. They may be in different molecules after the chemical reaction, but they don't disappear. Okay? That law is a very important law in chemistry. It's called the law of conservation of mass. We must make sure that we follow that. Okay, so here we go. So someone tells me there's going to be a fizzing. I can see it. Can you see a fizzing?
Yes.
There's something happening, isn't there? Maybe I should add some more. When you do chemistry, it's very, very important for you to just add one drop at a time. Because sometimes when you have a chemical reaction, you'll get an observation taking place when you have one drop added, and then you get a totally different observation when you have several drops added. Okay? So this is starting to do something. It is definitely starting to fizz. I can hear it fizzing in here as well. Let's add a few more. Now, there's some definite bubbles forming, okay? Can you see that?
Yes.
All right, so what are those bubbles? What are those bubbles?
Carbon dioxide.
That's amazing. I don't even know what those bubbles are. I just see them as bubbles. Someone must have very, very special eyes to be able to see. I can see a gas. It's invisible. It's carbon dioxide. As a chemist, we need further proof. And I shall show you later on a liquid that will prove that it is indeed carbon dioxide. I'm going to do it with another chemical test. Let's see if we can see signs of a blue liquid. Can you see signs of a blue liquid forming now? See, and it's not, hopefully not just a blue liquid where you have a bit of green powder. Excellent. We should agitate this now. Okay. Now we're going to see the blue liquid. Can you see that? Can you see the blue liquid? Yeah. It's very plain to see now. Very plain. If I hold it very carefully, can you see how it's dark blue compared to the green powder that we had before? Yes? So, in chemistry, that's definitely a strong indication that we could have copper. Now, I want to ask, this is all fine and well, but what could this be useful for? I get asked a lot. What do we need chemistry for, sir? Surely this is just to keep kids unhappy in school because they have to learn and memorize the periodic table and formulae and so on and so forth. Who has fish in here? Raise your hand if you have a fish in a... Oh, I don't want to ask. Maybe that's a very sorry tale. Do you not have that fish anymore? Yusuf, do you not have that fish anymore? What happened to it? He's fine. Are you okay? You can talk to it. You're not okay. You're okay about the fish. You okay to talk about the fish? It's okay. All right. I don't want to upset you. Okay. I don't want people going home and saying, I was upset by Mr. Khan because he brought up the story of the fish. You were okay. Now, was it he or she? You don't know. Oh, really? All right, let's pretend. Did it lead a happy life? And and how many years did it live? Half a year. Oh my. No, the fish usually live. How small was it? How small? That's quite big. It should live for longer. Now, this fish, did you keep it in an aquarium? I'm very glad to hear that, because some people who keep fish in cages, they don't last for very long, right? And they don't. Have you tried it? You have tried it. Someone in here has tried to put a fish in a cage. It didn't last long. You'd never. All right. Okay. Thank you. You are wise. You are wise. And did you notice that in your aquarium that there was this green stuff that would grow? What is that called? Don't know. Anyone know in here? Anyone in the chat? No? Algae. Ah, Rawi. Thank you, Rawi. See, Rawi's our expert. And did you get rid of the algae in your aquarium, or did you just let it go green? You don't know. You didn't see it. Wow. Yusuf couldn't even see the fish. There was that much algae. Wow. Well, algae takes away the oxygen when the algae die. So decomposing algae remove the oxygen that fish need. That could suffocate a fish over a long period of time. So perhaps you needed to have some of this. This copper sulfate is actually the active ingredient that people add to aquariums to get rid of unwanted plant life in an aquatic environment. So I went to a pet aquarium center next to Lulu's hypermarket only yesterday, because our aquarium is starting to grow some algae. And they sold this to me for 65 dirhams or 39 dirhams, and it was about that much. And I've just made it in front of me right now. So this is a very, very useful byproduct. Can you see all that fizzing? Can you see the fizzing now? Good. I've had to wait until it reacts completely. I had to buy some time, so we had to talk about the aquarium. Can you see how beautiful this blue color is now? Can you see that? It's like a beautiful sapphire, isn't it? A royal blue. I love that color. Yeah, love that color. Are you convinced? You're convinced. Good. Right. Now, what's the next experiment that we need to do? This is how it comes. Zinc metal granular. Okay. Bad for fish. Don't give fish zinc. Okay. I love, as a chemist, I love looking at metals. Look at that. Isn't that spectacular? Yeah, subhanallah. Look at that. This is 99.5% pure, extra pure. Contains, out of more than 99 atoms out of 100, contains only one type of atom. It's an element. Okay? Metallic bonding. That's what makes it so difficult to prise apart. It's malleable. I can pull it, and it can form wires. Ductile. I can even tap it. It makes a slight dull ringing sound. Sonorous. Okay? Tested all of that. Isn't that fantastic? Now, apparently, all I need to do is put a couple of lumps of this into a test tube. I'm going to have to try my best. Didn't anticipate this happening. These don't fit. I've got the use of a if we can crush it a little bit and then pop it in there. I'm going to have to tell my lab technician not to be so generous with the size. I want to try and get them into a test tube, because I want to try a unique experiment. This one will go in. Will it go in? There we go. Right. I just have to do that 20 more times and we're good. So, come back in 3 hours, okay? There we go. That's good enough. Now, I'm going to safely put all of these bits of zinc back. And we have a potential reaction that will take place with an acid. What I'm going to do is I'm going to zoom up here. I'll show you the whole setup in a second. We've got some dilute hydrochloric acid here. Okay, and our zinc sample is there now. If it starts to fizz, I'm going to catch any gas that is made using this boiling tube that fits on top. Very clever. Now, this will only work if the gas that's made is actually a gas that rises in air. If it sinks in air, any gas that's made will fill the test tube up and then just flow over and then just get lost on my desktop. The gas that's actually made is lighter than air. It's one of the lightest gases that exist. What is the gas that's made? Hydrogen. Okay? Hydrogen is the lightest gas in existence. It makes up a great deal of our universe, the known universe. It is what makes today very hot. Because hydrogen is the energy store, the chemical energy store inside the sun. And a nuclear energy store, right? Now, this chemical reaction may appear to be very slow, but what we can actually do is we can use some of that liquid that we used earlier, that we formed earlier, which was called copper sulfate. We can actually use that to speed up the chemical reaction. It's called a catalyst. I'm going to go back to that sample and add a few drops. And we're going to then start to see the experiment really speed up. Okay. Now there are some bubbles already, so it's happening quite well. Just going to add a tiny drop of this, because I know that this speeds the chemical reaction up quite nicely. There we go. It's really happening now. Oh, we've got a live one here. We have got a live one here. Now, let that happen for a little while. And in the meantime, I need to tidy up a little bit. And I've got a little burner here. I'm going to set light and making sure that nothing else is flammable around me. Everything is safe. Everything is secure. I just need a source of ignition. I nearly set fire to my laptop then. That would have been interesting. There we go. Yeah. I just realized I can't blow a match through a face visor and a mask. I automatically tried to blow, and all I just did was just warm my face, which is quite interesting. Right. Now, someone said that there's a chemical test that can be done for hydrogen. What is that chemical test? Let's see. Hands up, anyone? Hydrogen. It's a chemical test that can be done to test this mysterious gas. Hands up. Yes, Zara.
Use a wooden splint and flame and if it makes a pop sound or a pop, then it's hydrogen.
Wow. Shall we try it?
Yes.
Are you suggesting to me that I get this gas and I light it and let it explode? That sounds very dangerous. Have you done this before, Zara?
No.
But you want me to do it?
No, sir, that was that.
Oh. Oh, was that Taj? I thought it was you, Zara. I don't know about you, but I'm a little scared now.
I
Someone has
answered the question, but Dad said asked you to do the experiment. She said yes.
Someone suggested to me that I now set light to a very explosive gas, and I'm feeling a bit nervous. And I've got 5 individuals in front of me that should be feeling quite nervous as well. Are we sure about this? You know, I've got a wife and kids. What's going to happen? All right. If anything happens, tell my wife and kids I love them. Should we try it? I'm scared. I'm too scared. Aircon on. Right, okay. Oh, I'm a bit scared. Are you sure nothing's going to happen? All right, we'll give it a try. Okay, but I just want to make sure that if I have a flame, I'm not producing any smoke. Otherwise, the school needs to be evacuated. I'll douse it straight in there. Right, okay. Are we ready? Let's go. Let's see. I don't want to do that again in a hurry. Did you see that? Did you see that? Can we do it again? Okay. All right. Now this is feeling very, very warm. Very warm. And it wasn't anything that I lit. I'm going to add a little more acid just in case, because it's the acid that is actually providing the hydrogen ions that are then turning to hydrogen gas. There we go. Pop that there. Now you'll notice there wasn't much of a squeak. The reason why was because I allowed a long time for the hydrogen to fill up the boiling tube. And it's only when you have the right mix of oxygen and hydrogen that you actually get what's known as a squeaky pop. Because the hydrogen needs oxygen to explode, to combust. And this is the principle that's behind rocket launches. There we go. Classic test. Good. What's the next experiment? What's the next experiment? I thought it was maybe neutralization. You want to do that? Or should I do the... well, while I've got heat, there was the decomposition of copper carbonate. Yeah. Thermal decomposition. So let's return back to our copper carbonate. Okay, it's Yusuf's book, he won't mind. Let's return back to the copper carbonate. Now, remember I said earlier, I needed proof of carbon dioxide. And there's another experiment that I can do that can generate carbon dioxide. Copper carbonate, I think, is one of them. You heat copper carbonate, what happens? So, one of the experiments was a test tube and a delivery tube apparatus. This is in the book, and this is on your mat, I believe. And what I've done is I've made it a little bit more COVID pandemic teaching friendly. I'm using 2 beakers here just to hold all the apparatus. And inside this one, I'm going to put some copper carbonate. Okay. Now, just to save some time, I made a little paper dispenser. I'm going to take the sticker out in a second. And on your sheet, you should have a reference to a liquid called lime water. Put your hand up if you've spotted that. On your sheet, lime water. Can you see it? Yeah, put your hand up. Lime water, a test for test for carbon dioxide. Am I right? Yes? Is it on there? Because you need to tell me, otherwise I get things wrong. Is it on there? Is it on there? Copper carbonate, testing for carbon dioxide? Good. You're going to see that. Good. I've just had it verified that that was one of your, that was one of the things. Right. Now what I'm going to do is I'm going to seal this. And this is completely able to give off gas, any gas that's made. Copper carbonate's a very nice one because when you heat it, it actually undergoes a thermal decomposition. That means it breaks down. It's very unstable as a compound. And it breaks apart. And it forms black copper oxide. It doesn't get burnt, it forms a new compound. And it loses its carbon dioxide very, very quickly. This lime water is used. This is not lime water as in I'm squeezing a lime into water. This is not 7-Up. It's actually the chemical name given for calcium hydroxide. So this is not something that you would want to have with your chips and chihuahuas, trust me. And I'm going to get some of this lime water. Now this lime water has no color. So just like I said on the sheet, oh look at that. That's a wonky pipette. There we go. It's lime water. Totally colorless. Can we all agree with that? Yeah, you can see through it. Not a problem at all, yeah? It's very important that you observe that. Now what I'm going to do, I'm going to heat the copper carbonate. I'm expecting it to go black. I'm going to see what happens. Can you see everything? Just about. Come on. There we go. Oh, I'm missing something. Just a safety tongue so I don't okay. I'm going to move this so you can see it as well. There we go. So that, and then I hold it there. Yeah. Ready? So that's green and colorless to start off with. Green powder. Okay. Now it's not going to get burned. It's a chemical reaction that's taking place on the inside. And now you can see the bubbles coming through on the right-hand side. Now, first of all, it's just air from the vessel. It's just being pushed through. But what's pushing it through? A gas is being lost from the green compound. It's decomposing, it's breaking down. Part of it is being lost. And that part is the carbon and some of the oxygen. The carbon dioxide is being lost. Now, If enough carbon dioxide is lost, you should start to see a change in the lime water. Here is the change in the lime water. Can you now see that it's turned like a milky, cloudy white? That is actually calcium carbonate precipitate. And that only forms when carbon dioxide is added to the lime water. So this is a positive chemical test for carbon dioxide. So now I can say, yes, this is carbon dioxide. Because there's a lot of invisible gases that are out there. Nitrogen, hydrogen, oxygen, nitrogen, yes? Carbon dioxide, carbon monoxide, methane, they're all colorless. It's very, very important as chemists that we actually have a way in which to say, yes, this is what this is. And this is the chemical test for lime water. Okay? A good one. There was one final experiment I think I wanted to show you today. Something to do with acids and alkalis. Yes? Have a look. Acids and alkalis on your sheet. What was the test? Someone got their hand up? Anyone? Something about acids and alkalis. When you add an acid to an alkali, to a metal hydroxide, you get salt and water. This type of reaction is called a something reaction. It's the bottom right hand side. Neutralization. Thank you. Right. I need you good. Low line on that side. Without going near her. Low line on that side. Thank you. Yeah, just lower the line. Now, the issue with neutralization is that it is a fabulous reaction, but much of the magic that happens is, I'm afraid to say, something that we can't see. Because you're talking about something that, for example, involves an acid, an alkali, and more often than not, I have to say, they're invisible. What invisible? They're colorless. They're not invisible. I can see this. Right. They're colorless, I should say. So here is an example. This is representing an alkali. Okay, specifically it's a base and it is soluble in water, so it's like an alkali, but it's representing a metal hydroxide, but in actual fact it is it's a carbonate. So it behaves like an alkali. You're going to see that very shortly, so I don't have to prove it to you. And here's the acid. You saw the acid earlier. This is dilute hydrochloric acid. I don't have to worry about that too much. There's no hazard warning on the sodium bicarbonate because this is bicarbonate of soda. This is something that you have in your kitchen. You use it as baking soda. Many of you add it to breads to just puff it up a little bit. So that's perfectly fine. That's perfectly fine. So, this is a world exclusive. I'm not going to beat around the bush. I invented this experiment. I invented it today. With the specific intention being to show you what happens when an acid reacts with an alkali during a pandemic. Now, in year 7, you may have come across this, called universal indicators. Should be indicators, there's several different ones in there. It's flammable, so the flame is off now. Health and safety, risk assessment. And its natural color is green. And in neutral solutions, it should be green as well. I'm just going to add a little bit here. Hopefully, you should be able to pick up greenness. I'll add enough, don't worry. And I'll adjust the camera, so don't worry. We'll just get the stuff in there first, okay? All right. So universal indicator is very, very useful, incredibly useful, because it will allow us to monitor what we can't see happening between the acid and the alkali. I'm going to need a little bit of water just to top it up. So this is distilled water. It contains nothing but water. Containing nothing at the moment, so just there it is. So water is neutral. You recognize that from your year 7. Water gives a pH of 7 in the universal indicator. None of you are agreeing. I'm dreading to think that you may have forgotten about this since year 7. You recognize that? No. My goodness me. Can you see a green color? You can see it, yeah? Isn't that beautiful? Take a moment just to look at the beauty. See if we can get the color at a different angle. How's that? Is that a bit less strong, less intense? Yeah? Good? Right. So, what I'm going to do, I'm going to have to exhibit some real skill, technique here. I'm going to use diffusion to get the acid to mix with the alkali. Now, I will remind you, because I'm your chemistry teacher. When an acid is in universal indicator, like a strong acid, like hydrochloric acid, it comes up as red. The pH is around about 1 to 2. A strong base is roughly maybe 12, 13, 14. Its pH is around about that range, and its color is purple. So this end is going to be purple, and this end is going to be red. This end. Let's add them on opposite ends, and let's see what happens. Again, this is a world exclusive. You are the first to see this, ever. I'm going to call this pandemic antimony. And what you need to look out for are shifts in color towards the yellow and the reds. You need to see them. And hopefully you'll start to see also some patterns. Right, let me just use the free cam so I can get a better angle. Because what you're seeing may not be what I'm seeing. Can you see the patterns? You see the patterns of colors? So where there's green in the middle, neutralization has taken place. Can you see that swirling color? It looks like it's like a mysterious planet, doesn't it? Wow. How about that? What do you think? What do you think? No one's saying anything. Everyone is silent. Can you see what I'm seeing? You see how you've got red on the acid end, which is here. That's where the acid came in. This is where the alkali is. Just show you that. This is where the alkali is, here. And it started to neutralize in the middle. And that's why you've got the yellows and you've got the blues. Because the acid is reacting with the alkali. And eventually, as I can see right now, you have a nice little layer of green. There's some green here, and there's some green there. And that's neutralization. So an acid reacting with an alkali forms a salt and water, and the acid and the alkali are not triggering. Do you have to go somewhere? Someone's packing up their pencil case right now. Do you have to go anywhere? No. You should be looking at the screen. Thank you very much. Some people have forgotten how to be in school. I haven't got a train to catch. Thank you. I will stay as long as it takes, because I love this. What do you think, Nada? Amazing, isn't it? I'll tell you one thing. I don't know whether I'll have a chance to maybe see if I can get this photo to you, but what I'm seeing is absolutely brilliant. Let's get a real close up there. You see, it's like fractals in maths. It's like a nebula, doesn't it? In an outer galaxy. So next week, we shall continue our investigations on the reactions of acids. We shall take it forward. Thank you very much for joining today. I hope you enjoyed the lesson. It's some real chemistry. Take care. Bye-bye.